Alrighty, my friends, this is going to be the easiest and fastest derivation of the Gibbs-Helmholtz equation. I doubt your prof is going to show this to you. I don't even know if your prof knows it, but it's totally valid. We're going to start off with the Gibbs energy equation. Change in Gibbs energy equals the change in enthalpy minus temperature times the change in entropy. And we're going to solve for the change in entropy here and talk briefly about what this represents. So imagine we do some process at some temperature. It's going to have an associated change in Gibbs energy with it. If we do the same process at a different temperature, there'll be a different change in Gibbs energy. But what we're going to assume is that the change in enthalpy and change in entropy are constant. So it doesn't matter what temperature we do the process at, delta S will be the same and delta H will be the same. That's our assumption. So if we make that assumption, then the stuff on the left-hand side here is equal to a constant, equals to delta S. And it's going to be equal to the same thing if we were to do it at a different temperature, because they both equal delta S. And this, my friends, is the Gibbs-Helmholtz equation. This is it. We just need to rearrange it into a more familiar form. So we'll move all the terms with a G to the left, all the terms with an H to the right, factor out the negative change in enthalpy to give us the Gibbs-Helmholtz equation in its integrated form in all its glory. We could differentiate this to get the differential form if you wanted to, but that's pretty cool. Now, our assumptions are that the change in entropy and change in enthalpy are temperature independent. And just note, we're not losing anything with these assumptions because we require these assumptions for the other derivations as well. We're also assuming that there's pressure volume work only, so no electrical or other types of work, and for a closed system. Show this to other people. You may impress someone at a party. I do have other derivations, also exam problems on this. Best of luck to you. Good luck on your midterms, final exams. Hang in there. Cheers.